Okay, welcome back, everybody. We talked about patterns and functions in our last lesson, and we're going to jump into the I do portion, which is me modeling and presenting some example questions to you, and hopefully take those words from your notes and actually apply them to specific problems here. So, what are our directions? Please write a function rule for the information presented below. So we're going to make our own function rules. If you remember in our last video, we were talking about hours worked and then how much you earn. And we gave the example of, let's say I work at McDonald's and I'm making $7 an hour. Remember, we did that 7 times X, which would be the number of hours worked, equals my Y. And who knows how many hours I worked? Maybe 1 week I worked 12, and then the next week I worked 35. Your X value is going to change, but your Y value is going to be completely dependent on whatever you plug in for your X. So we're going to do a lot of problems very similar to that, and we need to write our own function rules by looking at these 3 charts. So number 1 has to do with laundry, as you can see there. So suppose you are washing and drying clothes at a self-service laundry. The relationship between the number of loads, the input, and the cost, the output, is a function. Use the table to write a function rule. So I'm going to write a function rule kind of over on the right, but I want to almost label what that problem just said. So it said the input is the number of loads, okay? So this right here, the number of loads would be your input. But remember, another word or another way of describing the input value is also the X, okay? And then the cost is going to be the output in our function. And the cost or output is also called the Y value. So that hopefully will clear up where things go when writing our function rule. Okay, so let's look at the number of loads. And this just goes up 1, 2, 3, 4, giving us the number of loads that you do. That's pretty self-explanatory. I don't think I need to get into that too much. But let's look at the Y. Okay, so if you do 1 load of laundry, it is $2.75. Okay, if you do 2 loads, it jumps up to $5.50. Okay, the next load, if you did a 3rd load, it would be $8.25. So I can't really tell just looking at that how much those are jumping up each step or with each load. So a good way to figure that out is to go to, in this case, I'm going to take the second. So let's say 2 loads was $5.50, and the first load was $2.75. I'm actually going to subtract load 2, that cost, from load 1's cost, and that will tell me the difference or what it jumps to from 1 load to 2 loads. So let's do that. 0 minus 5. We can't do that. We need to borrow from the 5. Okay, so that becomes a 4. We hand a 1 over to that 0. 10 minus 5 is 5. 4 minus 7, we also can't do that. We need to borrow from the next 5 over. We'll make that a 4 and throw a 1 onto that 4, making it a 14. 14 minus 7 is 7. And then 4 minus 2 is 275. Okay, so that little quick bit of math helped me to realize that, okay, to go from 275 with 1 load to 550 with 2 loads is jumping up 275. And then me just eyeballing it, I can kind of tell that to go from 550 to 825 is going to be another $2.75. And then one last time, if you do 3 loads, it's $8.25. If you do 4 loads, it's $11. And I know if you add $2.75 to $8.25, you're going to get $11. So basically what we figured out here is that with every load, it costs $2.75. So let's see if we can write a function rule for this problem. So $2.75 is the first thing we're going to write. Okay? So 275, if we take that times the number of loads that we do, which is going to be X, so $2.75 times X is going to give us our Y. So simple as that. A function rule for this chart is 275, which is $2.75, times X is going to give us our Y. So if you only do one load, it's going to be $2.75. If you do $2.75 times X and you do two loads, 275 times 2 is going to be $5.50. I'll do one more, 3. If we do $2.75 times 3, or our X value, it's going to equal our Y value of $8.25. So I hope that makes sense with number 1. The answer, or the function rule that we created there, is 275 times X equals Y. Number 2, write a function rule for the relationship between the number of hours, the input, and the number of miles, the output. I kind of like labeling these. So hours, just to make life easier for me, it just told me that's going to be the input, which is another term for the X value. And the total miles is going to be the output, or the Y value. So hopefully that gets you started on your writing a function rule for this particular one. So as just like above, hours is the top line, and it goes up just 1, 2, 3, 4. But with every hour, for me, and it may, I don't know if you can do this, and if not, that's okay. But I can kind of eyeball this and say, okay, it starts at 60. Hour 2, it goes to 120. Hour 3, I see it jumps to 180, and hour 4, it jumps to 240. And I'm fairly certain that it's going up by 60 every hour, right? To go from 60 to 120, you have to add 60. To go from 120 to 180, you have to add 60. So I'm pretty confident that 60 seems to be the jump that we're making with each hour. So I'm going to write 60. The X value is going to be the number of hours. So we're going to plug that in as the X. So 60 times X. And then if you take 60 times the number of hours, it's going to give you your total miles, which is Y. Always a smart idea to go back and double check your answer. So let's just look at it. And I'm not going to go all the way 1, 2, and 3 like I did above, but let's just check our work by going with hour 3, or 3 hours. Okay, so if every mile you're going, every mile it's increasing by 60. If we do 60 times X, which in this case is 3 hours, so 60 miles times 3 hours is going to give us our Y output of 180. So our function rule is going to be 60 times X equals Y. Very last problem, let me scroll down a little bit here. So there we go. Okay, the relationship between the number of houses, the input, and the number of toothpicks, the output, is a function. Use the table to write a function rule. Now, everybody, this is going to get a little bit trickier. And I'll show you why. So number of houses, or the input, is going to be the X. And the total number of toothpicks is going to be our Y. Now let's study the numbers that we have here. So for every house, it seems to be going up. What is it? Me, I can eyeball this and tell you, but if you're not sure, remember like we did in number one, in this example, maybe take 11 and subtract it, which is the second. If you have two houses, take that 11 and subtract it by the number with 1, which would be 6. So 11 minus 6 would be 5. I can eyeball that, but remember, that's a good way to figure it out if you can't eyeball it. But going from 6 to 11, you're adding 5. Going from 11 to 16 is 5. Going from 16 to 21 is also 5. Okay, but here's the thing that's a little bit goofy, is that it doesn't start off at 5 from the beginning. It starts off at 6. Okay, so that's going to make an additional step for our function that we're going to write. Okay, so just to show it to you, if we look up here at these little stick figure houses, notice that the first house has 1, 2, 3, 4, 5, 6 toothpicks, right? But the second house only has 5, and I'll show it. I'm sorry, not your second house, but if you were to add another one onto that, another house, you'll see why it's only 5. So this is our first house, right? I'm going to redraw it. But if you do a second house, you don't have to count this right here because it's already there. That toothpick's already there. Okay? So in blue, for the second house, instead of needing 6 sides, it needs 1, 2, 3, 4, 5. This right there is not needed because there's already a toothpick making up that side of the house. So that is our reasoning for it, but how do we make that as a function? And I'll show you how. So we notice that it goes up by 5 every single house that you build, but the original house has 6. So here's what we'll do. Let's do our x value, and it's going up by 5. So our function rule is going to be 5 times x. Okay? And that's going to, eventually going to equal our y. But we need to account for that additional toothpick. Okay? So in order to account for that, what we're going to do is we're going to add it right into our function rule. Plus 1. Okay, so it goes up by 5, except that first that first house has an additional toothpick, making it 6. After we start off at 6, then from there on, it goes up 5 toothpicks per house. So we need to account for that additional toothpick up front. Your answer is going to be 5x plus 1 equals y. So let's just go with this one as an example. Let's plug this in. So 5 times the number of houses. So let's do 5 times 4 houses. We're going to account for that 1 extra toothpick at the beginning equals y. 5 times 4 is 20 plus 1 equals y. 20 plus 1 is 21. And hey, look at that. It matches exactly what our chart says. Okay, so that's a little introduction in drawing and in creating functions. We will continue to work on this as the week proceeds. Have a good one.